solutions produces the largest number of dissolved particles, total ions and or molecules per mole of dissolved solutes? Oh, um, that's an interesting question, and I'm going to have to think about that. Um, anyway, so let me answer it uh, because I gave you some concentrations here. Anyway, I don't know what I'm going to do with this question. I think I'm going to just change this. So let's change this question on the fly, and I'll change it later today. It says, which of the following solutions produces the largest number of dissolved particles, total ions and or molecules? So because I have some concentrations and I have a number of substances here, so let's go ahead and work through this. So in order to do this, we need to know what kind of electrolytes each of these materials are. So HClO4, if you remember, it is a strong acid. And sodium chloride, strong acid, strong electrolyte. Sodium chloride is a strong electrolyte. So the molarity in the compound formula here should be CH3COOH. That is a weak acid because it has the COOH group in the back. Weak acid and therefore a weak electrolyte. And the C6H5OH has carbons, hydrogens, and oxygens. Sometimes they even just have carbons and hydrogens, but it has carbons, hydrogens, and oxygens, and it does not have the COOH group, which means it's a non-electrolyte. Okay, and so from there, zoom in a little bit, I guess. See if we can focus. From there, all right, so from there, we know that the HClO4 strong acid, strong electrolyte breaks up 100% into ions. 100%. And what that means is if we start with 1.1 molarity of HClO4, it breaks up 100% into 1.1 molar H plus. Apologize, my video is not very, hopefully you can read this. I think you can. 1.1 molarity H plus and 1.1 molarity perchlorate ions, which are ClO4 minus. That means that our total ions, or our total ion concentration, is 2.2 molarity. Okay. And so I'm going to just write 2.2 molarity here, and I'll write total for the total ion concentration, or total particle concentration, I should say. Now, what I just said is going to also happen for sodium chloride. Sodium chloride will break up into sodium and chloride ions. That means that if I have 0.75 molarity sodium chloride, I will double that because there are two ions, and I get 1.5 molarity. Now, let's talk about this weak acid. So a weak acid will break up less than 5% into ions. And so what that means is that if I start with 1.5 molarity or molar acetic acid, let me write the reaction here, CH3, COOH. So if I start with 1.5 molarity acetic acid, and it breaks up less than 5%, what that means is that at the finish, I will have less than 5% H pluses plus CH3COOH, or sorry, COO minus, less than 5% because these are my ions. And for the whole molecule, meaning did not break up, that will be greater than 95%. And I'm not sure if this makes sense, but I'm going to try it anyway. So if I start with 1.5 molarity, and then it breaks up just a tiny bit, I will end up with a little more than 1.5%, or say 1.5 molarity ions and molecules. Because a tiny portion split up into more than into two parts. So most of it's the same, but a tiny part split up into two parts, which gives us a little more than 1.5 molarity of our products. So I'm actually going to write, well, I don't know if I have space up here, but this one is a little more than 1.5 molarity. So 1.5 molarity plus, I will write, it's a little more than that. Now my non-electrolyte, I have 2 molarity of it, but my non-electrolyte does not break up at all. It dissolves and it stays as whole particles. So I'm just going to write 2.0 molarity there. And that is the entire process for figuring out which one has the largest number of dissolved particles. It is going to be my HClO4, my perchloric acid, because it has the largest concentration times the largest number of particles, so compared to the sodium chloride. Any questions about that? I don't know why I cannot get this to focus very well, and I apologize for that. I keep trying stuff.
Hey, Dr. Miller.
Yes.
Hey, it's Michael Davis.
Hey, Mike.
Will that answer change when you edit it in Blackboard to remove the per molecule of dissolved solute? Not your answer, but when I'm doing it in Blackboard, does Blackboard, well, if I answer it in Blackboard now, would your method of